All right, you guys, let's talk about MVP charts. And there's a lot better way to do this than I think we did in class. So imagine that you have a blue car that is 1 kilogram, 1 kilogram blue car, and it's traveling at 10 meters per second, and it slams into a red car that is 3 kilograms. And this thing is still. This is just like in the demonstration that we did with those little carts. And after the collision, it's a perfectly inelastic collision. So these guys are stuck together. These guys are stuck together after the collision. So we have kind of a total mass here of 4 kilograms. And our question is, how fast is it going? Meters per second. How fast is this thing going? So what we want to do is we want to create an MVP chart. Okay, so the best way to do this is we create our chart like this, MVP, and we create a little box. And we're going to divide the box up into 3 columns. And it's going to just like this. Just like this. And we're going to kind of have this is the before, and this is the after. Okay. The before had this blue car situation and a red car situation, and after they were connected. They were connected like that. Okay. The mass of the blue car was 1 kilogram, and it was going 10 meters per second, and the momentum was 1 kilogram times 10 equals 10 kilogram meters per second. And I know that because I know that momentum equals mass times velocity. And I could do the same thing here. This red car was 3 kilograms, and it was going 0 meters per second. 3 kilograms times 0 meters per second equals 0 kilograms meters per second. So I'm creating my momentum part of this chart down here. And then I'm going to use purple because red plus green, or red plus blue is purple. We know that the combined mass is 4 kilograms. We're going to try to figure out this box right here. And we can also figure out this box. Now, how do we figure out this box? Well, we know that the momentum, the initial momentum of the system before the collision is always going to equal the momentum after the collision. The momentum before the collision is going to equal the momentum after the collision. That's the conservation of momentum. Now, what was the momentum before the collision? Well, if we look, we can add up all the elements of our system here. So we had a momentum of 10 kilograms times meters per second for our blue car, and then we had 0 momentum for our at-rest red car. So our total momentum before the collision, this was 10 so this is 10 kilograms times meters per second, which means that our final momentum has got to be 10 kilograms meters per second, because momentum is always conserved. Kilograms meters per second. Now, how do we figure out this box? Well, we can use the same formula here, where we have P equals mv. So our momentum, 10 kilograms meters per second, equals 4 kilograms times x, or we'll just make it a question mark, and we could divide and we can solve, and you'll notice if we divide this, these kilograms will cancel out, and so we'll actually get a velocity of 10 force meters per second, and that's fine. And so this right here, that is an MVP chart. I hope that helped, and I hope that clarified a little bit. And there's some tools where we can algebraically solve for an unknown variable.